AP Calculus AB, looking at homework 1.6, focusing on the three-part definition of continuity. For exercises 1 through 3, determine if the function is continuous at each of the indicated values. Use the three-part definition to perform your analysis. Number 1, x equals -5. Well, at -5, there is a corresponding y value. So part 1, this is function. This function does not have a name. I'm going to name it function f. F of -5 equals 7. Therefore, f of -5 is defined. I don't want to say exists, I want to say is defined. 2 is the two-sided limit as x approaches -5. Does it exist? Well, according to our picture, the limit as x approaches -5 from the left of this function is equal to 1, and that is also equal to the limit of f of x as x approaches -5 from the right. Two-sided limit is the same. Therefore, the limit of f of x as x approaches -5 exists. The limit existence theorem. Part 3, does f of -5 equal this limit? And the answer is no, because this limit is equal to 1. So we would say, you know what, let me go back here a second. Let me say the limit of f of x as x approaches -5 is equal to 1 and exists. So then here I can say f of -5 does not equal the limit of f of x as x approaches -5. Therefore, f of x is not continuous at x equals -5. Boom. Number 2, x equals 1. Is the function defined at x equals 1? It sure is. It's defined as being 1. So part 1, we can say f of 1 is equal to 1. Therefore, f of 1 is defined. Part 2 is the two-sided limit. Does it agree? Well, the limit as x approaches -5, it's not -5, as x approaches 1 from the left. If you approach 1 from the left, it's approaching -2. That does not equal the limit as x approaches 1 from the right. Because if we look at our picture, if we approach from the right, y is approaching 1. So those two are not equivalent. Therefore, the limit of f of x as x approaches 1 does not exist. As soon as we get something that doesn't work, we can stop and we can say, therefore, f of x is not continuous at x equals 1. Part 3, I'm just going to bring this picture down here so I can see it better. We are referring to x equals -2 for this, I believe. Just going to put this picture here so I don't have to keep scrolling up. is the function defined at -2? F of -2 is -5. Clearly see when x is -2, the y value is -5. Conclusion, f of -2 is defined. Part 2, if you approach -2 from the left and the right, is it approaching the same number? The limit of f of x as x approaches -2 from the left is equal to -5. And that's also equal to the limit of f of x as x approaches -2 from the right. If you approach from the right or the left, it's approaching the same number of -5. Therefore, the limit of f of x as x approaches -2 is 5, and it exists. Part 3, does f of -2 equal the limit of f of x as x approaches -2? And the answer is yes, they're equal. I could also say what they're equal to. They're equal to 5. Therefore, f of x is continuous at x equals -2. Glorious. Number 4, use the 3-part definition of continuity to graphically justify why p of x is discontinuous at x equals 0 and x equals 2. Alrighty. Well, at x equals 0, that's easy enough, because we could just simply say that p of x is not defined at x equals 0. Let's see, p of x is not defined at x equals 0. Therefore, p of x is not, it says to use, it uses the word discontinuous, so I'm going to use that word. Is discontinuous. This means the same thing as not continuous. At x equals 0. That was easy. What about at 2? Is it defined at 2? It sure is. Does the left and right limits agree at 2? They do not. So part 1 of this, p of x is defined. Let me say this. P of 2 is equal to -1. P of -2, or P of +2 is equal to -1. Therefore, P of 2 is defined. The limit, part 2, of P of x as x approaches 2 from the left is equal to -1. But that's not equal to the limit of P of x as x approaches 2 from the right. Because if we approach 2 from the right, y is getting closer to 2. Therefore, the limit of P of x as x approaches 2 does not exist. Therefore, P of x is discontinuous at x equals 2. Make sure I answered the question. Use the three-part definition of continuity to graphically justify why this function is discontinuous. Yeah, we did that. All right, moving forward. For what values of k and m is the function g of x continuous everywhere? Use limits to set up and show your work. So to be clear, this function in itself is continuous because it's quadratic. This function in itself is continuous because it's exponential. It's actually linear. We'll get to that in a second. This function in itself is continuous because it is linear. The only place these could be discontinuous is where this one stops and this one starts. That's at -1. Or where this one stops and this one starts, which is at +3. So what we need is we need the limit of g of x as x approaches -1 from the left to be equal to the limit of g of x as x approaches -1 from the right. We also need the limit of g of x as x approaches 3 from the left to be equal to the limit of g of x as x approaches 3 from the right. We're getting these x values from the breaks in the domain. If we approach -1 from the left, that's this function here. So we're trying to find the limit of kx squared plus m as x approaches -1 from the left. And from the right, we're trying to, let me bring this to your attention right now. This little fella here, e to the natural log of 2x plus 3, that's just 2x plus 3. It's a line. Remember our exponential and logarithm rules. If your base is e raised to an exponent that's a logarithm, which this is the same as log base e of 2x plus 3. If the base of your base is the same as the base of your logarithm, this whole thing just becomes the argument. So that's just 2x plus 3. Let me change the color of this. For this red equation, we're trying to figure out what what our letter has to be. If you approach from the left of 3, that's the function 2x plus 3. If you approach to the right of 3, that is kx minus m. So solving this first one, to evaluate the limit, we're going to put -1 in for the x value. We're going to have k times -1 squared plus m. On the right, we're going to have 2 times -1 plus 3. It's going to be k plus m equals 1. We can't solve that because there are two variables. And you know what? No, did I make a mistake here? No, I did not. All right, continuing. For this other function, we're going to have 2 times 3 plus 3 equals k times 3 minus m. That's going to be 6 plus 3, 9 equals 3k minus m. We can't solve that equation either because there's two variables. So what we could do is we could stack these on top of each other using a system of equations. And I could say that 1 equals k plus m over 9 equals 3k minus m, and then add these together using the elimination method. And I would get 10 is 4k, which is going to make k 5 halves. And then once I have k as 5/2, I can take this other equation, well, either equation, I should say. I'm going to use this one because it's the easiest. 1 equals k plus m, and replace k with 5/2. Going to change 1 to 2 over 2. If I subtract 5/2 from both sides, I get negative 3 over 2 is m. So unless I made an arithmetic error someplace, k would have to be 5/2 or 2.5, and m would have to be negative 3 over 2 or negative 1.5. Moving on. Number 6. Find the value of a that would make each function below continuous everywhere. Write the two limits that must be equal in order for them to be continuous. Well, this is continuous, it's a quadratic. This is continuous, it's a quadratic. Wherever these two quadratics come together, if they come together at the same height, the whole thing's going to be continuous. So that means that the limit of 4 minus x squared as x approaches negative 1 from the left would have to equal the limit of ax squared minus 1 as x approaches negative 1 from the right. To evaluate these limits, we're going to put negative 1 in for x. That would be 4 plus 1 equals a minus 1. That would be 5 equals a minus 1. I got a is 6, which is a mistake. I got a little sloppy. 4 minus a negative 1 squared is a positive 1. So it should be 4 minus a positive 1, which is a 3. And if I add 1 to both sides, I'm going to get a 4. Pardon me. Number 7. For this to be continuous, where this domain breaks apart here at 2, if you approach 2 from the left, or if you approach 2 from the right, these limits should be equal. To evaluate the limits, we're going to put 2 in for x. See if we can solve this for a. 2 cubed is 8. See, so we're going to have 6 plus a is 8a minus 4. If we add 4 to both sides, we get 10. If we subtract a from both sides, we get 7a. So I got 10/7 is what a would have to be to make these continuous.